I'm going to be covering some notes on dimensional analysis, which is a tool that we use to show our work as we are converting from one set of units to another set of units. So dimensional analysis is also known as factor label method. It's a method that allows us to move or convert from one unit to another. And we use our unit conversions or unit factors to multiply or divide to help us convert from one unit to another. It also allows us to show all of our work during our problem sets. That way I can kind of track what you're doing, and then it makes it a little bit easier for me to see where we've made mistakes and how to correct those. So I'm going to go through some examples of how dimensional analysis works. Again, it's just sort of a method of showing our work as we move from one unit to another. I think it's really helpful. I think it's really clear. So I'm going to start with a really simple example of using dozens. So dozens is a unit that we're all pretty familiar with. And 1 dozen is equivalent to 12. So for this simple example, we're going to talk about bagels. So 1 dozen bagels is 12 bagels. So usually what we would do is somebody would tell you like, oh, I need 4 dozen bagels. And you would have to figure out like how many bagels that is. And for most of us, that's a pretty simple math. We know that a dozen is 12 bagels, and in our head, we already are sort of doing unit conversions. We know that in order to go from our 4 dozen bagels into number of bagels, that most of us pretty confidently would multiply by 12. Now, why do we multiply by 12 as opposed to divide by 12? And it's actually because we're doing this sort of method of dimensional analysis, but in our brains, kind of so fast that we're not even realizing that we're doing it. What's actually happening is we know that 4 dozen bagels is our initial unit. And if we're using the unit conversion, 1 dozen being equal to 12 bagels, we can use that as what we call a conversion factor, or almost like a ratio. So you can either say that you've got 1 dozen per every 12, or you can say that you have 12 bagels per every 1 dozen. Right? So either of those are true. They're saying the same thing. So saying 1 dozen is equal to 12 bagels is the same as saying 1 dozen per 12 bagels or 12 bagels per 1 dozen. So we call these conversion factors. So when we look at these over here, these are now our conversion factors. And you would pick one of those to use in order to convert from bagels, dozens of bagels, to actual bagels. So we're at 4 dozen bagels. So what we would do is we would take one of our conversion factors and we would multiply it. So I'm going to go ahead and set up my conversion factor right next to it. And if I remember back to when we were talking about how we do math with numbers, we have to remember that our units act like math variables. So if you've got grams over grams, that would cancel. If you have centimeters times centimeters, it becomes centimeters squared. So then I pick my unit conversion sort of based off of what unit I want to cancel and what unit I want to be in. So I want to be out of dozens of bagels, and I want to be into bagels. And so if I look at this, I know that it's for every 1 dozen bagels, I have 12 bagels. So that's the unit conversion I'm going to use. So every 1 dozen bagels is 12 bagels. Let me move my parentheses out here. Okay. So then all I'm going to do is actual math. So it becomes 4 times 12, and then technically divided by 1. And so what I'm going to do is I'm going to multiply that, and I'm going to get 48. Technically, it's dozen bagels, because my units act like math variables. So dozen bagels times bagels is my unit up top, over dozen bagels. So when I look at this, my dozen bagels cancels, and I'm left in just bagels. So then I'm going to erase all of that, and I'm going to write just the unit that I'm left in. which in this case is bagels. So 4 dozen bagels is equivalent to 48 bagels. Okay, so we're going to do that one more time, but sort of in the other direction. So let's say I give you a certain number of bagels, and then you have to figure out how many dozens that is. And so I'm going to keep the math simple here because we're going to make it a little bit trickier as we go on. So in this case, let's say I give you 36 actual bagels. And the question is, how many dozens of bagels do I have? So I go back to that idea of my conversion factor. And again, I'm going to use this as my conversion factor. So this is the fact that remains true. 1 dozen bagels is 12 bagels. So I'm going to make my parentheses. Let's see here. Let's see how my numbers fit. Okay, so I've got 36 bagels. I want to get out of bagels. I don't want to be in that unit anymore. And this is technically on top, right? So 36 bagels, technically over the number 1. So bagels is right now on top of my fraction. So I want to get out of bagels, so bagels has to go on the bottom. So I'm going to put 12 bagels, right, on the bottom. So I know that 12 bagels is equivalent to 1 dozen bagels. I'm saying bagels so many times. Okay, so then when I do my math, when I put it in my calculator, it's technically going to be 36 divided by 1, right? But that's just 36. So it's going to be 36 times 1 divided by 12. And when I do that math into my calculator, it's going to come out to be the number 3. And then technically, my units are going to be bagels times dozen of bagels over bagels. But what's going to happen is that because bagels are over bagels, bagels cancels, and you're going to be in dozens of bagels. Okay. All right. So that's how we're going to use our unit conversions. I'm going to go through a bunch more examples, but hopefully that feels familiar because hopefully you feel comfortable going from dozens to like numbers of things and numbers of things into dozens. So we're going to get into some more complicated examples where we're using other conversion factors. So I've got a problem here. We've got the Star of India weighs 563 carats. So that's a unit. We know that every 1 carat is 200.0 milligrams. And then the question says, what is the mass in grams? So there's a couple of conversion factors here that I'm going to be using. So the first one is stated here. So it's telling me that a carat is 200 milligrams. So I'm just going to write that right above it so I remember that that is a conversion factor. That is a relationship between units that I can use. So 1 carat is equivalent to 200 milligrams. Now, the other thing I have to keep in mind is that the question is asking you to go to grams. So what do I know about grams and milligrams? Well, I know that there are 1,000 milligrams, because they're small, in every 1 gram. So that's going to be another conversion factor that I can use. And I'm going to do this one in 2 separate steps, but then in the other ones, I'm going to start showing you how you can kind of show all your work without stopping in between. So the initial unit, the initial number that I have is 563. So I have 563 carats. That's how much the Star of India weighs. And now I want to get out of carats, and I eventually want to be in grams, but I don't know how many carats are in a gram. So instead, I'm going to use this conversion factor up here because it was given to me, and I know how many carats are in, or how many milligrams are in a carat. Now, when I'm looking at this, I'm going to use a conversion factor. So I'm going to take that fact that I know. So here's my fact that I know about carats and milligrams, and I'm going to turn that into a conversion factor. Now, I'm already in carats. So again, if you like to think of this over the number 1, you can write that. That's helpful for some people. I want to get out of carats and I want to get into the milligrams. I want to get into another unit. I don't want to be in carats anymore. So I'm going to put 1 carat on the bottom so that carats will eventually cancel. And 1 carat is 200 milligrams. So then I'll go ahead and let carats cancel, And then when I put that in my calculator, I come out with, I think, oh, that's a big number, 112,600 milligrams. Okay, great. So now I'm in milligrams, but I don't want to be in milligrams. I want to be in grams. So what I'll do next is I'll take that number and I'll basically do another problem. So I'm going to make this a little bit smaller. Give me a second. Okay, so I'm going to take that number that I got in milligrams. So 112,600 milligrams. And I'm going to convert that into grams. And so I want to get out of milligrams. And I know that every 1,000 milligrams is 1 gram. So that's my other conversion factor. So here's my other fact, right? But I want to get out of milligrams. So I'm going to put milligrams on the bottom so that it cancels. So 1,000 milligrams for every 1 gram. I'll go ahead and then do my math. So milligrams will cancel. It's going to be this number times 1 and then technically divided by 1,000. So I'll go ahead and plug that in and I get 112.6 grams. And so now I can say that the Star of India weighs 112.6 grams. Okay, so technically you don't need to stop in the middle here. You can just sort of continue doing your conversion factors until you get to the unit that you're trying to be in. So that's sort of what I'll show you next. So I'm going to go down here and skip to this school day 1. All right, so school is 179 days, and you take 4 classes a day that last 70 minutes each. How many seconds are you in class each year? So basically it's asking you how many seconds you're in class each year. So let's go ahead and start that off. I know that my starting number is 179 days. That's how many days you're in school. And I want to know more about your classes. So I've got a conversion factor already up here. So we know that you have 4 classes per day. So that's the same as saying 4 classes equals 1 day for you. Because we want to do how many seconds you're in class each year. So we want to be into class information. So you have 4 classes in every 1 day. And then we know that each class, so we know that 1 class also is the same as 70 minutes, is equivalent to 70 minutes. That's how many minutes you're spending in each class. And then we're eventually going to get to seconds. So there's going to be a third fact that we know, and that's that there are 60 seconds in every 1 minute. So we're going to be using those 3 facts and turning them into conversion factors to use in order to convert from one unit into another. So we're starting at 179 days, and we're going to move into seconds. So my first conversion factor I'm going to do is this one here, because I want to know how much time I'm spending in class. So I know that I'm in class 4 of them for every 1 day. Now, if you stop here, that's going to tell you, if you do the math, right? If you take 179 times 4, that's going to tell you that you take about 716 classes per year, per the 179 days. So that's going to come out to be 716 classes. Okay, then we want to know, okay, so if you are spending in those 179 days of school that you have, and you have 716 classes altogether, and you spend 70 minutes in each class, how many minutes are we spending in class? So we're going to go into minutes. So we know that each class, so 1 class, is equivalent to 70 minutes. So we've gotten out of days, we've gotten out of classes, and now we're into minutes. So then if you do the math, if you do 179 times 4, technically divided by 1, times 70, again, technically divided by 1. Now you know that you spend, I think, 50,120 minutes in class per 179 days that you spend in class in a year. Now, the last part is seconds. Like, how many seconds are we spending in class? Well, we know that every 1 minute, and I want to get out of minutes and into seconds, so I'm going to use that as my conversion factor. Every 1 minute is 60 seconds. So minutes will cancel, and I'll be left in seconds. So when I do all of my math all the way across, it's going to be 179 times 4 divided by 1 times 70 divided by 1 times 60 divided by 1. It's not always going to be divided by 1. It just happens to be so in this particular example. That I spend, or you spend, or we spend about 3,007,200 seconds in class each year, or in class for those 179 days of school that we have. So that's sort of how you would do them sort of all in a row without stopping in between. All right, we're going to do one more example together. I'm going to try to take it nice and slow so you can sort of see all my work as I go, and then you're going to be doing some practice problems on your own as well. Okay, so the last one up here, I saved it because we're going to be talking about like multiple units. We're not going to be trying to get into just one unit. We're going to be trying to get into sort of like a set of units. So in this case, a sprinter runs a 120-yard dash in 11 seconds. And it says to express their speed in miles per hour. And just as an extra fact, they're letting us know that there are 1,760 yards in every 1 mile. So some of the conversion factors you can look up if you don't know them off the top of your head, and those are helpful for you as you convert from one unit to another. And then I should mention that we are going to, in this problem, be going from hours to seconds, so those will be other conversion factors that we also are using. So I'm just going to list the conversion factors I know that we're going to need. So we know that there are 1,760 yards per every 1 mile, right? So that's equivalent to a mile. We know that there are 60 minutes in 1 hour, and we know that there are 60 seconds in every 1 minute. So we're going to be turning those into conversion factors as we try to move from one unit into another. So I'm going to start over here, and we know that this sprinter runs 120 yards per 11 seconds. So then you could figure out if you wanted to how many yards per second this person is running. So if I plugged 120 divided by 11 in my calculator, you could say that this runner is running 10.9 yards per second if you wanted to. So you could start like that if you wanted to, but you don't have to. It's sort of up to you. I'm not going to. I'm just going to start with yards on top, seconds on the bottom. I don't really care that there are numbers next to them. And then I'm going to use my first conversion factor, and I'm going to use this one over here because I want to go ahead and get into miles. Now, I want to express it in miles per hour. So if I'm looking over here, when I think of miles per hour, mathematically, that's going to be miles over hour. So miles per hour. So I want the miles unit to be on top and the hours unit to be on the bottom when I'm finished. And that's pretty important as I'm going through this, that I make sure that my units are in the correct places. So the first thing I'm going to do is I'm going to use this conversion factor here to get out of yards and into miles. So I'm going to go ahead and set up a set of parentheses, and then I'm going to turn this into a conversion factor. Now I want to get out of yards. So if I want to get out of yards, that typically means yards is going to go on the bottom. Oh, sorry about that. Doop. Okay, so I'm going to put yards on the bottom so that they eventually cancel. So 1,760 yards per every 1 mile. That's going to get me out of yards mathematically and then into the mile. So now mile is left on top, which is where I wanted it to be. So now I'm not going to touch the mile part anymore, and I'm just going to convert out of seconds and into hours. So if you stopped right now and you did 120 divided by 11 times 1 divided by 1,760, technically your answer would be in miles per second. That's where we're at right now. But that's not what the question asks. So now I'm going to do another set of conversion factor. But this time I'm going to get out of seconds and I'm going to get into, I guess, the minute, because that's what I know. So I know that for every 60 seconds, that is equivalent to 1 minute. I want to get out of seconds, but right now, if I look at seconds, seconds is on the bottom. So if I want seconds to cancel, I need seconds to go on top, and I need minute to go on the bottom, because seconds over seconds is what's going to cancel. If I put seconds on the bottom, that's going to become seconds squared, and that's not right. So I'm going to go ahead and write that conversion factor in. So I know that there are 60 seconds for every 1 minute. Make sure your conversion factor is true, right? Like don't mix up your units and your numbers just because they look better. So you can't say that there are 60 minutes in 1 second, right? Because that's just not a true fact. So whatever you're writing as your conversion factors has to be true. And so in this case, right, it's 60 seconds per every 1 minute. All right, so then now if I look at it, right, I'm out of seconds because seconds would cancel. And I'm going to try to go from, I'm in minutes now. So if you did all of your math all the way across, technically you would be in miles per minute. So I'm going to do one more conversion factor. And I want to get out of minutes. Keep in mind minutes are on the bottom, so I want to put minutes on the top so that they cancel. And I know that there are 60 minutes in every 1 hour. And so that's going to keep hour on the bottom for me because that's where I wanted it, miles per hour. And then I'm going to go ahead and do my math all the way across. So minutes cancel. Keep in mind I'm just canceling the units, right? Numerically, you still have to put everything into your calculator. So numerically, in my calculator, I'm going to put 120 divided by 11. Then that number times 1 divided by 1,760 times 60 divided by 1 times 60 divided by 1. And when I do all of that math in my calculator in the right order, I think I get 22.3 miles per hour. So 22.3 miles per hour. And then that's my answer. Okay, so hopefully that was sort of helpful. You're going to be doing some conversion factors. So the whole point is that you're showing all of your work. You're showing your units canceling. You're showing what units you're currently in. And we're going to be using this worksheet that you're going to be getting in class. So the first thing I want to do is remind you about some of our metric units, and then you're going to be doing some conversion factors and some dimensional analysis on just some practice problems below. Okay, so let's sort of just review our metric units. So kilo means thousands. Centi means hundredths, right? Because they're like little tiny. Milli means thousandths. That THS is important at the end because that's, again, they're really tiny. And micro is super small. That's millionths. It's like a million of them to make up something. So they're super small. I really like whole number ratios. I think I talked to you about that before. But you can use whichever one is easier for you to remember. So 1 kilometer is the same as 1,000 meters because a kilometer is big. So it takes 1,000 meters to make up a kilometer. 1 gram is 100 centigrams. So centigrams are small, right? Because that's 100ths. So it takes 100 of them to make up a gram. Milli, if you remember, is small. So it takes 1,000 of them to make up a liter, and then micros are even smaller, so it takes 1,000,000 of them to make up a gram. Again, I like whole numbers, and that's typically what I'll use, and you'll see in my work, but you can also use the fraction. So 1 meter is small compared to a kilometer, so it is 1,000ths of a kilometer. A centigram is really small in comparison to a gram, so it is 100ths of a gram. Milliliter is even smaller than a liter, right? So they're really tiny. So they're 1,000ths of a liter. And then a microgram is super small, so it is 1,000,000ths of a gram. So this is saying the same thing as this. They're just saying it in slightly different ways, and you can use whichever one you like. Just know that when I show my work, I always use these like whole number integers because that's just my personal preference. But you're not wrong if you use these because if you use these ones over here because that's just the way that you like to remember them, that's fine. So I'm going to do a couple of these and then you guys can do them in class. So I'll walk through the first one with you. So the first one, you're going from kilograms to grams right here. And so we're starting at 45.9 kilograms. Remember, we're using dimensional analysis, so the whole point is that you're showing your work. And I'm going to be using the fact that there are 1,000 grams in every 1 kilogram, right? And then I'm going to turn that into my conversion factor so I can see myself as I move from one unit to another. So then I'm going to say, okay, times my conversion factor, right? And I want to get out of kilograms. So I want to get out of kilograms, so kilograms needs to go on the bottom. So that kilograms over kilograms cancels. If I do that, that means my 1 kilogram goes on the bottom, and 1 kilogram is equivalent to 1,000 grams. So 1,000 grams goes on top. Remember, this conversion factor needs to be a correct ratio. Like it needs to be true. Otherwise, all of your work's going to be wrong. So then mathematically in my calculator, I'm going to type in 45.9 times 1,000, then that technically divided by 1, and I should get 45,900 grams. Remember, kilograms cancels. Or if you like, you can write at the end, right? You can write that technically it becomes kilograms times grams over kilograms, and then you can see over here that kilograms over kilograms cancels and that you're left in grams. If you like doing it like that, that's fine. You will see me instead canceling them over here, but always making sure that a top unit, if I'm trying to cancel it, that it's going to show up on the bottom in order for it to cancel. All right. Last one I'm going to do with you is just a 2-step problem. So we'll do one of these ones down here. So when I think about numbers, I don't have centimeters to kilometers memorized. I just know that 100 centimeters is the same as 1 meter. That's just a thing that I know. And that because a kilometer is so big that there are 1,000 meters in every 1 kilometer. So I'll be using those two as conversion factors in order to get from one unit to another. So if I start with 1.090 times 10 to the 4th, oh, that's right, that's in scientific notation. I'm in centimeters right now. So my first step would be to get out of centimeters. And it's okay that I'm getting out of centimeters and not jumping straight into kilometers because I don't know that conversion factor off the top of my head. So what I'm going to do is I'm going to use this first fact up here as my conversion factor. So I'm going to go ahead, and I know I want to get out of centimeters. So I'm going to put centimeters on the bottom. So it's the 100 centimeters part has to go on the bottom. So 100 centimeters is 1 meter. That's going to make sure that my centimeters cancel. And then mathematically, when I do this math, so this number times 1 divided by 100, that answer would technically put me into meters. But I don't want to be in meters, so I'm going to do one more step. And I'm going to get out of meters and into kilometers. So that's the next conversion factor that I know, because I'm going to use this fact. So I know there are 1,000 meters in 1 kilometer. I'm already in meters, so if I want to get out of meters, I need to put meters on the bottom. So that means I'm going to put 1,000 meters on the bottom. So 1,000 meters is the same as 1 kilometer. Meters is now going to cancel because there'll be meters over meters. And then when I do this math, I'm going to be left in kilometers. I'm going to write my answer down here. So in my calculator, I'm going to put 1.090 times 10 to the 4th. Technically times 1 divided by 100 times 1 divided by 1,000. And that's going to give me my answer in kilometers. I haven't done this problem in advance, so let me go ahead and throw it in my calculator. So I got 1.090 times, I'm going to use my EE button, 10 to the 4th, and then times 1 divided by 100, and then times 1, and then divided by 1,000, and I got 0. Oh, that's the wrong pen. I got 0.109 kilometers. All right, so that's how you're going to do dimensional analysis. You all are going to go through and kind of finish up these worksheet problems. You're going to work on the next page. And then when we talk next, we're going to start talking about a new unit called the mole. And so all of this is in preparation for using the mole and sort of converting from the mole into other units.